IBM Advanced Data Science Capstone Project. Title: Airbnb Rental Price Prediction in New York City. Table of Contents. Chapter 1. Data Acquisition. The process of collecting the data from the source. Chapter 2. Data Exploration. Data exploration is an approach which uses visual exploration to understand the data set. Chapter 3. Data Wrangling. Data wrangling is the process of cleaning and unifying messy and complex data sets for easy access. Chapter 4. ETL and Feature Engineering. Feature engineering refers to a process of selecting and transforming variables when creating a predictive model. Chapter 5. Data Partitioning. The process of splitting data into train validation and test for building a model. Chapter 6. Data Modeling. Modeling is the statistical technique that is chosen to find trends, patterns, and relationships within existing data. Chapter 7. Model Selection. Based on various metrics, the best model will be chosen for implementation. What is Airbnb? Airbnb is an online marketplace for arranging or offering lodging, primarily homestays, or tourism experiences. The company does not own any of the real estate listings, nor does it host events. It acts as a broker, receiving commissions from each booking. The company is based in San Francisco, California, United States. Airbnb is a platform that connects people who want to rent out their homes with people who are looking for accommodations in that locale. It currently covers more than 81,000 cities and 191 countries worldwide. The company's name comes from Air Mattress Bed and Breakfast. New York City is the most populous city in the United States. With an estimated population of 8.4 million distributed over about 784 square kilometers, New York City is also the most densely populated major city in the United States. New York City has been described as the cultural, financial, and media capital of the world, significantly influencing commerce, entertainment, research, technology, education, politics, tourism, art, fashion, and sports. Home to the headquarters of the United Nations, New York is an important center for international diplomacy. New York City received a record of almost 63 million tourists in 2017, and Manhattan hosts 3 of the world's 10 most visited tourist attractions: Times Square, Central Park, and Grand Central Terminal. The aim of our project. As we have already mentioned, Airbnb is a platform where millions of hosts and travelers list their space and book unique accommodations anywhere in the world. Airbnb affects the city's housing supply and affordability. In a modern, busy cosmopolitan like New York City, there are so many competitions for housing and huge demands for accommodations. Airbnb pricing is important to get right. If the price is too high, the hosts might risk losing customers, while if the price is too low, they might be missing out on potential benefits. The goal of our project is to come up with the appropriate prediction of Airbnb price using machine learning, so the hosts can achieve optimal profits. One of the challenges we faced is that since the raw data we used consists of both categorical and numerical values and missing values, which makes classification more difficult. Project description. Context. This data file includes all needed information to find out more about hosts, geographical availability, necessary metrics to make predictions and draw conclusions. Content. Since 2008, guests and hosts have used Airbnb to expand on traveling possibilities and present more unique, personalized way of experiencing the world. This data set describes the listing activity and metrics in New York City. Acknowledgement. The data set is obtained directly from the Airbnb website. Specifically, this data set describes the listing activity and metrics in New York City as was in June 8, 2020. Objective. The objective is to create a best model to predict the rental prices of the Airbnb listings throughout New York State and also create clusters based on all the variables to create a data structure and segment the data. Planning, execution, and implementation. Here we will be using various machine learning algorithms to predict the best model for rental prices and segmentation, then we will select the best suited one based on the metrics for implementation to achieve the goal of the project. Chapter 2. Data Exploration. Pandas Profiling. After acquiring the data set from the source, we can explore it to understand the various features present in the dataset and its characteristics. In Python, there is a special package to do this all exploration of data into a single step known as Pandas Profiling. The Pandas Profiling Python package is a great tool to create HTML profiling reports. For a given data set, it computes the following statistics: essentials, type, unique values, missing values. Quantile statistics like minimum value, Q1, median, Q3, maximum, range, interquartile range. Descriptive statistics like mean, mode, standard deviation, sum, median absolute deviation, coefficient of variation, kurtosis, skewness. Most frequent values. Histograms. Correlations highlighting of highly correlated variables, Spearman and Pearson matrices. New York City encompasses 5 county-level administrative divisions called boroughs. In our data set, borough is called neighborhood group. These are Manhattan, Brooklyn, Queens, Bronx, and Staten Island. Each neighborhood group, boroughs, has been drilled down into fine locations as neighborhood whose count is 222. Among the neighborhood groups, Manhattan have the least number of unique neighborhood locations, 32, but at the same time have the highest number of Airbnb listings, 21,963, in the whole New York City, which means that this is a popular site, thus more travelers and tourists and thus the large number of rental places. Therefore we can expect that the average rental price to be higher than the other boroughs. Brooklyn have the second highest number of unique neighborhood locations, 48, and also have the second highest number of Airbnb listings, 19,931, in the whole New York City, which means that this site is also as popular as Manhattan. Therefore we can expect that the average rental price will be higher than the other boroughs but not as expensive as Manhattan borough is. Queens have the highest number of unique neighborhood locations, 51, but less number of Airbnb listings, 6,068 rental places, than Manhattan and Brooklyn, which indicates that the Queens is not much popular site, therefore less tourists and less rental spaces. Hence we can expect a low average rental price for this borough. Bronx have the same number of unique neighborhood locations, 48, as Brooklyn but have a few number of Airbnb listings, 1,198, which means that this site is less popular. Hence we can expect a low average rental price for this borough. Staten Island have the second smallest number of unique neighborhood locations, 43, but have the least number of Airbnb listings, only 370, which means that this site is not popular at all. Hence we can expect a low average rental price for this borough. We can see that the number of Airbnb listings in each borough is what influences the price, and there are more number of Airbnb listing in Manhattan and Brooklyn. From the counterplot, we can see that most of the Airbnb properties are located in Manhattan. From the box plot, we confirm that the Manhattan region also consists of a high variance in terms of prices as compared to the other regions. We also notice some outliers in the prices for other regions, i.e. prices above $1,000. From the plot of distribution of room types by neighborhood groups, we observe that prices for entire home and apartment is the most listed by the hosts. The demand for private rooms and entire home rentals is greater as compared to the other room types. As most of the hotels are located in Manhattan, the other boroughs consist mostly of private or shared rooms. Next, we create a visually appealing matrix of pies to allow the reader to see which neighborhoods are booked the most and better inform their decisions and opinions. Room types and their availability. From the above, we can see that we have few number of shared rooms, as usually the travelers and tourists prefer to have a space for them without any disturbances. Therefore entire home and apartment and private rooms are more popular and have more availability. We don't have much Airbnb listings in boroughs of Staten Island and Bronx, hence we will be having less numbers of rooms in all categories. Likewise, we have more number of Airbnb listings in both Manhattan and Brooklyn, but the ratio of the rooms in each borough is almost the same. In this plot, we see the distribution of Airbnb listings by neighborhood group across New York City. From the above spatial analysis, it is evident that there are a lot of Airbnb listings in both Manhattan and Brooklyn and very less Airbnb rental spaces in Staten Island, as our data analysis indicate. In this plot, we see the price distribution of Airbnb listings across New York City. From the above, we can see that the average price of rent is the same for the boroughs of Bronx, Queens, and Staten Island. Brooklyn is more expensive than the three neighborhood group mentioned above. Finally, we must notice that the rent price is highly overpriced in region of Manhattan. In this plot, we see the price distribution of Airbnb listings with price below $600 across the boroughs of New York City. From the above, we can see that more than 80% of Airbnb listings in New York City with price below $600 are located in boroughs of Manhattan and Brooklyn. In this plot, we see the price distribution of Airbnb listings with price above $600 across the boroughs of New York City. From the above, we can see that almost 3/4 of Airbnb listings in New York City which price is above $600 are located in borough of Manhattan. In this plot, we see the distribution of room types across the boroughs of New York City. From the above spatial analysis we can see that the Manhattan has more number of entire home and apartment, orange points in the graph, compared with private rooms, blue points, and Brooklyn has more number of private rooms than entire home and apartment. In this plot, we see the distribution of Airbnb listings by neighborhood group across New York City. In the above plot, red dots represents less availability of rooms throughout a year, and green dots represents more availability. We can notice that the boroughs of Brooklyn and Manhattan are having less availability of rooms due to its popularity, and on the other hand the boroughs of Staten Island and Bronx have more availability of rooms as because it's less popular than the above two boroughs. In this plot, we see the availability of Airbnb listings across the boroughs of New York City. From the above plots, we can see that there is less availability in private rooms and more availability in hotel rooms. Heat map. As we can see from the correlation map, most of the variables aren't really correlated, but we can learn some more by analyzing their correlation with each other. The heat map is a very powerful tool, and it can show us many things. In our case, it's important to point out observations on price. Latitude is the most correlated variable with price, which emphasizes one of the most important concepts of real estate: location matters. However, this is a slight indication of higher prices located in the northern parts of the city. Manhattan, which is the most expensive borough of New York City, is located to the north side of the city. Longitude seems to be negatively correlated with price, meaning that one can expect higher prices as position in New York City moves to the western parts of the city, emphasizing again to the importance of location. Price is also positively correlated with availability 365, showing the fact that some Airbnb rental places are rented by hosts who list other properties, increasing the number of minimum night. Price is negatively correlated with number of reviews and reviews per month, indicating that it is possible that the prior reviews could depress the prices to some extent. Other interesting observations. Calculated host listings count is positively correlated with minimum nights and availability 365, indicating that hosts who list more than one property may think more strategic rather than opportunistic about their rentals. That may attempt to maximize the amount of time a single renter stays at their property to minimize turnover cost. They also tend to maximize the amount of time the property is being rented. Data exploration. Conclusions. The closer you are to Midtown and the lower Manhattan area, the more expensive it gets. The average price for an Airbnb rented space in New York City is $162.7 per night. The percentage of Airbnb listings not available in New York City is 40.6%. The average minimum number of nights you need to get an Airbnb listing in New York City is 8.2. Chapter 3. Data wrangling. From the above, we can see that the features last review and reviews per month are missing about 23% of the data, hence we will be replacing null values in their columns with 0 in the data set. We will also be dropping the features ID, name, host ID and host name as they possess insignificant relationship to the target variable price, and also these are textual data. Finally, we will examine if we have data with price equals to 0, and we will be dropping the 0 prices from the data set. We use a library to better visualize the missing values and the correlation between them to better know if they have type MCAR, MCR, or MNAR. There is a correlation between two columns, last review and reviews per month, which is normal. Data cleaning. First, we will check the insignificant features with respect to the target variable based on p-values by using as user-defined functions. From the above results, we can see that the calculated host listings counts has an insignificant relationship with the target variable price, so we will remove it. Then, we check whether any multi-correlation is present between the independent variables in the data set by user-defined functions. The correlation between the features reviews per month and number of reviews is about 0.75, hence we will remove one of them, reviews per month. Pair plot will be used to find whether any variable can be able to differentiate the price distribution. In our project, we will be using the neighborhood group feature. From the above plots, we can see that the price distribution, target variable, is heavily skewed towards right, positive, and the neighborhood group variable is not separating the price distribution well as it overlaps on each other. We observe the same through violin plot when we have tried to know about the average price of rent based on neighborhood group. Statistical distribution of data. We can see in the histograms above that the variables minimum nights, number of reviews and price have outliers. To better understand these data, we examine the statistical summary of the variables using the command describe. Looking at this summary, we can come to some conclusions. The variable minimum nights as its max is way over the real limit, which it is 365 days. The 75% values of all the analyzed variables are a lot lower than the max value for each variable. Finally, we decide to drop the following records. Listings whose minimum nights is more than 30 days, which represent 826 entries or 1.7% of the whole data set. Listings whose number of reviews is over 120, which represent 2,444 entries or 4.9% of the whole data set. Listings whose price exceeds $1,000, which represent 328 entries or 0.7% of the whole data set. Chapter 4. Extract, Transform, Load, and Feature Engineering. We decided to add another feature to our original file, which is the distance from the nearest subway train station, believing that it plays a decisive role in the price of Airbnb rental spaces. The subway system is the main public transportation system in New York City. The New York City subway is one of the world's oldest public transit systems, one of the most used and the one with the most stations. The New York City subway is the largest rapid transit system in the world by number of stations, with 472 stations in operation, 424 if stations connected by transfers are counted as single stations. The system typically operates 24 hours 7 days a week, every day of the year, barring emergencies and disasters, though some routers may operate only part-time. By annual ridership, the New York subway is the busiest rapid transit system in the Western world, as well as the 9th busiest rapid transit rail system in the world. In 2017, the subway delivered over 1.7 billion rides, averaging approximately 5.6 million daily rides on weekdays and a combined 5.7 million rides each weekend. The system is also one of the world's longest, containing 394 kilometers of routes. For each Airbnb listing ID file, we go through each subway stop and calculate its distance from each subway stop. Then, we store the minimum distance value in a distance to station array, so that we can keep track of the minimum distance to the subway for each Airbnb listing ID. Because this exercise is computationally expensive, we choose to export our data table to a new CSV file. Skewness. We examine if an independent or a dependent variable has a right skew, mean greater than median. Then, taking the log would make the distribution of our transformed variable appear more symmetric, more normal. There are no regression assumptions that require our independent or dependent variables to be normal. However, because we have outliers in our dependent and independent variables, a log transformation could reduce the influence of these observations. The variance of our regression residuals are increasing with our regression predictions. Taking the log of our dependent and independent variables may eliminate the heteroscedasticity of residuals and thereby improves the fitness of the model. Then, we proceed to logarithmic transformation for the next features of our data set. Availability 365. Days since last review. Distance to station. Minimum nights. Number of reviews. Price. Data pre-processing and feature engineering. Summarizing our work up to this point, we proceeded to the following actions. We have removed columns not required for training of model, ID, name, host ID, and host name. The column reviews per month was also dropped as it had a strong correlation with the column number of reviews. An added feature, distance to station, was created from the data set of train station locations. Numerical variables are normalized using logarithmic scaling. Categorical variables such as neighborhood, neighborhood group and room type are converting into dummy variables. Chapter 5. Data partitioning. We split the data into train and test split with 75% and 25% respectively. There are various methods of scaling such as min-max scaling, standard scaler, normalizer, max ABS scaler, and robust scaler. In our project we will be using robust scaler as we need to nullify the effect of outliers even after logarithmic transformation. Chapter 6. Data modeling. First, we examine the baseline models. The three baseline models are linear regression, ridge regression, and lasso regression. Linear regression, to capture the linear relationship between the dependent and the independent variable. Ridge regression, regularized linear model which penalized the higher coefficients by using alpha parameter to eliminate the overfitting issues. Lasso regression, least absolute shrinkage selective operator which penalizes the higher coefficients by using the parameter alpha to eliminate the overfitting issues and helps the feature selection. Then, we examine the ensemble models. An ensemble method is a machine learning technique that combines several base models in order to produce one optimal predictive model. When considering ensemble learning, there are two primary methods, bagging and boosting. Bagging involves the training of many independent models and combines their predictions through some form of aggregation, averaging. An example of a bagging ensemble is a random forest. Boosting instead trains models sequentially, where each model learns from the errors of the previous model. Starting with a weak base model, models are trained iteratively, each adding to the prediction of the previous model to produce a strong overall prediction. Presentation of ensemble models. Decision tree. It uses a decision tree as a predictive model to go from observations about an item, represented in the branches, to conclusions about the item's target value, represented in the leaves. It breaks down a dataset into smaller and smaller subsets while at the same time an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. KNN regressor. The KNN algorithm uses features similarity to predict the values of any new data points. This means that the new point is assigned a value based on how closely it resembles the points in the training set. Random forest utilizes bagging, bootstrapping and aggregating strategy with base eliminator as decision tree and creates a number of trees based on which the model predicts. Here all the trees are independent to each other. Gradient boosting regressor in which all the weak learners will be combined to form a strong learner. Here, decision tree is the base estimator and all the estimators are dependent on each other, learns by residuals of the previous decision tree. XGBoost regressor. Extreme gradient regressor provides an efficient implementation of the gradient boosting algorithm. The main benefit of the XGBoost implementation is computational efficiency and often better performance. Light GBM regressor. Light gradient boosting machine is a gradient boosting framework that uses tree-based algorithm. It splits the tree leaf-wise with the best fit. So when growing on the same leaf, the leaf-wise algorithm can reduce more loss than the level-wise algorithm, like XGBoost, and hence results in much better accuracy. Artificial neural networks. Artificial neural networks are computational algorithms. It intended to simulate the behavior of biological systems composed of neurons and inspired by a central nervous system. It is capable of machine learning as well as pattern recognition. K-means clustering. K-means clustering aims to partition n observations into k clusters in which each observation belongs to the cluster with the nearest mean, cluster centers or cluster centroid, serving as a prototype of the cluster. Model evaluation strategy. Mean absolute error. Mean absolute error measures the average magnitude of the errors in a set of predictions, without considering their direction. It's the average over the test sample of the absolute differences between prediction and actual observation where all individual differences have equal weight. Root mean squared error. Root mean squared error is a quadratic scoring rule that also measures the average magnitude of the error. It's the square root of the average of squared differences between prediction and actual observation. R-squared score, R-squared score, also known as the coefficient of determination, measures the amount of variance of the predictive model. Training error is the error that we get when we run the trained model back on the training data. Remember that this data has already been used to train the model, and this necessarily doesn't mean that the model once trained will accurately perform when applied back on the training data itself. Test error is the error that we get when we run the trained model on a set of data that it has previously never been exposed to. This data is often used to measure the accuracy of the model before it is shipped to production. The results of linear regression model, ridge regression model and lasso regression model are almost identical. Their R-squared score ranges from 55.4% to 55.5%, and their test score is almost 19.5% for all three models. The R-squared score for the decision tree regression model is 54.9% and his test error reaches 19.7%. The R-squared score for k-nearest neighbors regression model is 54.7% and his test error approaches 19.8%. We must mention that KNN algorithm doesn't work well with high-dimensional data. With large number of dimensions, it becomes difficult for the algorithm to calculate distance in each dimension. The KNN algorithm has a high prediction cost for large data sets. This is because in large data sets the cost of calculating distance between new point and each existing point becomes higher. Finally, the KNN algorithm doesn't work well with categorical features since it is difficult to find the distance between dimensions with categorical features. The default random forest regression model gives a score of 59.5%. But notice, training mean squared error is significantly smaller than testing mean squared error, which indicates that there is an overfitting problem. To solve the overfitting problem, we need to cut down features of less importance and apply cross-validation. The finally results for random forest regression model give R-squared score of 58.7% and test error 18.1%. The default random forest regression model gives a score of 59.5%. But notice training MSE is significantly smaller than testing MSE, which indicates that there is an overfitting problem. To solve the overfitting problem, we need to cut down features of less importance and apply cross-validation. Our variable importance feature selection is taken from our tuned random forest model. We calculated predictor importance as a measure of how that predictor compares to the most important predictor and use this percentage to quantify the importance of each predictor. We then sort and plot our predictors on a horizontal bar chart, highlighting the most important features at the top and the less important features at the bottom of the graph. These are the most important features of our dataset. Entire home/apt, this feature indicates that the type of the listing room type, entire home/apartment, private room, shared room, and hotel room. This is appealing to guests that prefer privacy and are willing to pay a premium for this feature. It makes sense that this would be one of the most important variables because two listings can have the same features and aesthetics, but differ on price mainly due to the fact that an entire home/apartment features one party as opposed to other room types that require the guest to share the space with others. Longitude and latitude, this captures the location of the Airbnb listings. Certain neighborhoods and locations, due to their proximity to key attractions, will have naturally more expensive properties than others, especially in Manhattan, which is the most expensive borough in New York City. Distance to station, as anticipated, proximity to station to subway, train and other transit hubs plays a big impact in pricing. The ease of transportation associated with living closer to a subway station is attached with a price premium. Days since last review and number of reviews. Reviews provide valuable insight as to how past guests have assessed the space that a prospective guest is staying in. The most recent and the more reviews there are, the more information there is for a prospective guest to make an informed decision. Minimum nights. The duration of the lease of the Airbnb property plays a decisive role in its rental price. The lower it is the duration, the higher will be its daily rental price. Availability 365. This feature more broadly represents availability as a whole. This is potentially a feature that captures the supply aspect of the Airbnb listing. If there are a limited number of days for which the listing is available, the supply factor may affect its rental price. The R-squared score for the gradient boosting regression model is 58.9% and its test score approaches 18%. The R-squared score for the XGBoost regression model is a little smaller, 58.4%, and its test score reaches 18.3%. Finally, Light GBM regression model performs better, having R-squared score 59.6% and test score less than 17.7%. An artificial neural network was also trained on the data using Keras library on TensorFlow backend. The model was built using 2 hidden layers of 128 neurons on the first hidden layer and 64 neurons on the second layer. The sigmoid activation was applied on each layer except the output layer. A maximum of 50 epochs was trained using the ADA delta optimizer to measure the mean squared error and the mean absolute error of the artificial neural network model. The R-squared result of this model is 54.6%. Finally, we explore an unsupervised model which is k-means clustering. First, we try to find the optimal number of clusters to classify the dataset by using k-means algorithm, which is 5. By the visualization of how the clusters has been created based on each features, we can see some clear boundaries for the clusters only for the availability 365 and price. Examining the plot, we can see that the cluster 1, the red one, includes 30,717 Airbnb listings having availability less than 160 days and price ranges from $0 to $400. Cluster 2, the blue one, includes 78 Airbnb listings having all the availability and price ranges from $6,000 to $10,000. Cluster 3, the green one, includes 16,891 Airbnb listings having availability more than 160 days and price ranges from $0 to $400. Cluster 4, the purple one, includes 127 Airbnb listings having all the availability and price ranges from $1,600 to $5,000. Cluster 5, the orange one, includes 1,717 Airbnb listings having all the availability and price ranges from $400 to $1,600. Chapter 7. Model Selection. Comparison of baseline models. The results from the lasso regression model are similar to the ones from linear regression model and ridge regression model. From the comparison table, we can see that lasso regression model based on selected features could explain approximately 55.5% of the variation of price. We must notice that the difference between the baseline models are barely visible. Comparison of ensemble models and conclusion. From the result data frame, models adopting ensemble techniques performs better than linear models. Furthermore, ensemble models adopting boosting method have slightly better performance. Light GBM regression model has the best performance of 59.6% prediction accuracy score. Gradient boosting regressor gives a close second score of 58.9%. In addition, there could be less concern of overfitting in the boosting models due to the relatively lower differences between training and testing errors, even though there is no certain indication of overfitting issue here. Overall, the three ensemble models have very similar performances. The only defect in boosting method is time-consuming due to serial computing. Limitations of our models. Although we get impressive results from above regression analyses, there are still limitations of our project. First is that we use the logarithm of the price as the dependent variable in our models. This method makes the distribution of price more like a normal distribution and decrease the possible errors in the computation, but if we use the original price, the error may be enlarged. Second is that it is difficult for us to entirely understand the hyperparameter of each model, and our laptop's function also has limitation, so we can't get the best hyperparameters of models. Another limitation of our models is that we miss some important features, which render our models able to predict around 60% of the data set. One feature we think we miss is how the pictures of the Airbnb houses and apartments appeal to customers and how fancy they look. Future studies can take this feature into consideration. Thank you for watching.